Alright, so today what we're going to look at is the phase diagram for a pure substance. So it's important to keep in mind before we start, the description I'm about to give is for a pure substance and a pure substance only. So either, like, for example, water or hexane, but not a mixture, okay? Because those phase diagrams look a little different. So this description is only for the pure substance phase diagram. Alright. So on the vertical axis we have pressure, and on the horizontal axis we have temperature. This diagram, because of that, can sometimes be called a PT diagram. Alright, so on this diagram we have three main phases pictured: the solid phase, the liquid phase, and the gas phase. So what that means is that any combination of pressure and temperature that fall within this region is going to give you a solid. Any combination of pressure and temperature within this region is going to give you a liquid, and any combination of pressure and temperature within this region is going to give you a gas. Alright, so what is this here? This is the triple point. It's adjacent to the liquid, solid, and gas phase, and it exists at a single pressure and a single temperature. And this is a special combination of pressure and temperature where all three of solid, liquid, and gas can coexist. Okay, now the line coming up from the triple point to C, which is the critical point, so this line is called the vapor pressure line. It represents a line at which both liquid and gas can coexist. It can be thought of as the phase change line, and by that I mean it's all of the combinations of pressure and temperature along that line represent a saturated gas or saturated liquid, or somewhere in between. So for example, if you had a liquid at this pressure and this temperature, it'd be subcool. It would start off as a subcooled liquid. You would heat it up until it reached the vapor pressure line. So at the vapor pressure line is when the liquid will begin to boil and turn into a gas. But at that pressure and temperature, if the substance is still 100% liquid, then it's called what is known as a saturated liquid. Once all of that liquid has boiled off into the gas at the same pressure and temperature, is called what is known as a saturated gas. Now, if you continue to heat that saturated gas, it is called a superheated gas. All right. So, also of note is this line here, which represents a two-phase line between a solid and the liquid areas. So it would be what is called the melting point line. It is the line that represents the phase change between a liquid and a solid. Okay, and similarly, this line here, it is called the sublimation pressure line, and it represents the phase change between a solid and a gas. So at any combination of pressure and temperature along this line, you could have both solid and gas coexisting. All right. So what is the critical point? The critical point is defined by the critical temperature and the critical pressure. So at this temperature or any temperature above that, right? No matter what the pressure of the system is, you'll never get two phases. So you can't condense a gas into a liquid at temperatures above the critical temperature. So another way to say that is, along this line, okay, you can have two different phases. You can have a liquid and gas phase coexisting, and the reason why they coexist is because you have surface tension between the liquid and the gas. As you increase the temperature, that surface tension tends towards zero, and at the critical temperature, the surface tension is zero. So if the surface tension is zero, then you can't have an interface, okay? So you will never have two phases above the critical temperature. Similarly, at the critical pressure and above, regardless of your temperature, you'll never get liquid and gas coexisting. So basically, what a supercritical fluid is, it is a fluid that has properties between a liquid and a gas. Okay, cool. So another way just to think about this is if you had a like let's say for example, a liquid at this pressure and temperature, and you decrease the pressure isothermally, which means at the same temperature, all the way to the vapor pressure line, and then you have your phase change, right? We have two phases, liquid and gas coexisting, and then last bit of liquid evolves into the gas, and now you have only the pure gas, right? So at this point here, you would have two phases. Well, is there a way to change a liquid into a gas without having two phases at any point? Well, yeah, you could do that. You start here, okay, and then you increase the pressure and temperature until you get into the supercritical fluid region, okay, and then you decrease the pressure, and then you start decreasing the temperature back to here. At no point along this path are you going to have two phases. So there's a way to go from a liquid to a gas without having an interface between the liquid and the gas, or never having a two-phase system. So that's another way you could think of that. Alright, so I think that's more or less it. So yeah, cool. I think I'll make another video on a mixture phase diagrams, but thanks for watching this video, and I hope you learned something. Alright, I'll see you later.